Alright, guys, let's talk about trigonometry. It's my favorite subject to understand how trigonometry works. What is the reason behind studying trigonometry? Some of my math teachers did a great job explaining me all the formula and lot of fun stuff behind trigonometry, but I developed a deep appreciation for the subject only recently. It has got a lot of applications in real life, and I'm going to explain all that with you with a simulator called PHET. Hey, why is he opening a software for me and explaining trigonometry? It's simple. If you simulate something even once, you will understand everything. So get this software, which is free. There is a link in the description to pick up how to open this app and play with it. So now, where does understanding of trigonometry start? First is to know what an angle is. Angle is something that is formed between two lines touching the same point. So here there is x-axis and then there is this line along the radius of a circle. Why is this guy drawing a circle and calling this radius as 1 unit radius and using all that to explain how trigonometry works? Right? Let's skip that for a moment and try to understand why the angle is slowly increasing from 0 degrees to 10 degree to 15, 35, 40, 55. Slowly it reaches 90 degrees here. Right? The angle is slowly increasing. It goes up to 180, even goes up to 270 and further goes up to 360 and then it goes beyond 360 as well. So how much ever you go around this circle, you keep increasing the angle and you come back, you go in the other direction, you reduce the angle as well. It's beautiful, right? Angle is measured in degrees, and why 360 degrees make a complete circle? Again, I've said this many times, and it's one of the most beautiful things is imagine the sun being at the center and the red spot is the earth. How many days does it take for the earth to come back to the same place? It takes 365 days and 360 degrees because back then they could not accurately measure it. So they said it is 360 degrees, make a circle, divide it into 4 easily, 90 degrees, 45 degrees, so on and so forth. Shall we now get to the part about why trigonometry is useful and why it's called trigonometry? Trig means something is, there are three things. It could be three angles, three sides, and measurement involving three things at a time. What are the three things here? One is the origin, the center. The second point is the on the circle. The third point is where the 90 degrees is made. Right? Wherever 90 degrees is, there is a beauty of Pythagoras theorem comes, and you understand that there is some kind of special ratios also involved in that angle. Right? So now sine of this angle. What is sine of the angle is adjacent side. Let's forget about adjacent side. Let's move to the opposite side now. What is opposite side? This point's distance from the x-axis is called the y coordinate. That is the opposite side. The ratio of that opposite side to the hypotenuse is what defines sine theta. And sine theta, as theta increases, you always do not expect increase, but at some point of time it reaches the maximum and you start reducing. You go to the negative direction and then you go up to the positive direction and then you go on and forth, right? This beautiful movement of sine of an angle as you go around the circle is forms this beautiful wave down here, right? This is called the sine wave. This is how my speech comes to reach the microphone and reaches your ears right now. A lot of things in this beautiful world is happening because of the sine waves, right? Let's come to that part later. But what is cos? If you move to cos, you talk about adjacent side, not opposite side anymore. It is how the adjacent side grows and shrinks and grows and shrinks, and you keep looking at the blue line. As I rotate, it grows and shrinks and grows and shrinks so beautifully, right? And some points of time it grows really fast, some points of time it grows really slow. That is the slope of the curve in those areas. We'll get to slope in calculus, but this is just an intuition for you. It is beautiful how one more property comes into play. This is 90 degrees here, right? And this is called hypotenuse because your side opposite to 90 degrees is called hypotenuse. And when you mark an angle with respect to the hypotenuse, what you're getting is this ratio always remains a constant. What is the ratio? Something divided by something is a ratio. We are telling that adjacent side by hypotenuse is a ratio, and we are telling that that's the constant, that's called cos in this case. So if you increased this radius by 10 times, hey, I don't have a unit circle anymore. I have a big circle of 10 centimeters of radius. In that case, my adjacent side would also proportionally scale 10 times. This is the beauty of sine table and cos table, which was invented way back for understanding how the earth rotates and revolves. It's to understand the beautiful properties of the space. We have indulged in trigonometry as Indians way back. You can't even imagine. If you look up what is Madhava series, when the first expression for sine tables have arrived into the world, it is all fascinating. 300-400 years before, Newton and Leibniz and all those other beautiful inventors from Europe, and trigonometry, our curiosity for understanding the space, earth, the sun, and whatnot, is how it's beautifully connected to mathematics. So if you have not seen my space sky view video yet, please do watch that as well, and appreciate your time. Thank you so much.